Chapter 3, Lesson 4 of Pre-Calculus, we're working with properties of logarithms, and in this video I'm going to do a number of examples. I think there's about 30 total. So what you'll need to do is to kind of watch what you need to watch, and you can fast forward if you see one that looks difficult and you kind of want some help in walking through that. You can stop and watch it. So really this is a video where you're going to have to kind of move it forward or move it back depending upon what your needs are. I'm going to do 15 where we take a single logarithm like we have here and expand it into its expanded form using the properties of logarithms, and then I'll do 15 where we have an expanded form and we need to get it down into its condensed form into a single logarithm. Now that's probably the more important part of the lesson, because when we go to solving logarithmic equations, we're going to need to take multiple logarithms, condense them down into a single logarithm, because we need to change it to its exponential form in order to determine the value of x. So they kind of go from easier to harder, so you can kind of watch a couple if you think you have it and kind of move forward and stop and whatever fits your needs. So let's go ahead and tackle these. So we're asked to expand these logarithms, so we're going to use the properties of logarithms. So I have a number times a number, so we're going to use addition. So this is going to be log base 2 of the 12 to the 5th, and because we're multiplying, we add, so that's log base 2 of 5 cubed. So that is adding because it's multiplication. Now I also have an exponent raised to another exponent. So the power property says I can take this exponent and move it over into front. So this is going to be 5 times log base 2 of 12 plus, and then this has an exponent as well, log base 2 of 5. So this would be the expanded form of this logarithm. Okay. In our second example, again, we have a number being multiplied by a number, and we also have a power to it as well, so we're going to apply both properties. So the log base 8 of x to the 6th, that number is going to be added to the log base 8 of y cubed. Because those are being multiplied together, we add, and then we have this log base 8 of x, which is an exponent raised to another exponent, so the 6 can be moved out in front, log base 8 of x. And then this exponent can also be moved out in front. And so this would be the expanded form. Okay, I'm going to check my answer. I have the answers over here in another computer, so I'm just going to double check those and make sure I have those right. And we do. All right, so we'll go to our next example. In this example, we have a power to a power here, and so I need to handle this first. So what we're going to do is we're going to raise this, and to raise this we multiply these exponents together. Okay, so that's raising these powers to a power, and then we can go ahead and apply the properties. So I'm going to have log base 8 x to the 6 is being multiplied, so we add log base 8 of y to the 24th. And then again, we have these powers to powers, so we can move these out in front. So this is going to be 6 log base 8 of x plus, this is a power which can be moved in front, 24 log base 8 of y, and so this would be the expanded form of that one. Here again we have a power to a power, so this is a common log base 10, so this is going to be x to the 4th, y to the 24th. Now I'm multiplying these together, so that's going to be addition, log base 10 of x to the 4th, and plus log base 10 of y to the 24th. That is the product property, and then these both have exponents which can be moved in the front. So 4 log of x plus 24 log of y. In example 5, we have a cube root, so we'll need to change that to a fractional exponent. So this would be 11 to the 1/3 times 7 to the 1/3 times 8 to the 1/3. Now that we have these as fractional exponents, we can go ahead and expand this. I'm going to add these together because we have them being multiplied together. So it's log base 9 of 11 to the 1/3 plus log base 9 of 7 to the 1/3 plus log base 9 of 8 to the 1/3. Now these all have another power, an exponent being raised to a power, so the 1/3 can be moved in the front. So log 1/3 base 9 of 11, or 1/3 log base 9, excuse me, 1/3 log base 9 of 7, plus 1/3 log base 9 of 8. And so this would be the expanded form. And you could see that in a couple different ways, but we'll just leave it in that form. Okay, take a look at number 6. Again, because we have a cube root, we're going to need to change that to its fractional exponent. So this is a to the 1/3 times b to the 1/3 times c to the 1/3. So because these are being multiplied together, we're going to go ahead and add those. So this is a to the 1/3 plus log base 5 of b to the 1/3 plus log base 5 of c to the 1/3. And again, because we have powers to powers, we can put those in front. So this is 1/3 log base 5 of a plus 1/3 log base 5 of b plus 1/3 log base 5 of c. And so this would be the expanded form. Just checking my answer over there. Okay. All right, I'm going to skip up to example 10 here, where we have some division. Now, we have this, again, raised to a power, so I'm going to need to simplify this first. So we can take care of that, log base 6. So this is going to be u squared to the 6, so that's going to be u to the 12th. And then the v to the first to that is v to the 6th. So then I have that. Now, this is division, so we're going to subtract those exponents. So it's log base 6 of u to the 12th minus log base 6 of v to the 6th. And again, because I have a power here, I can move it in front. We're going to raise it a power. So 12 log base 6 of u minus 6 log base 6 of v. So this would be the expanded form. And I have that one right. Let's take a look at number 11 here, because something interesting happens here, because we have 3 being divided by 11 and 8. And the tendency here is to think that you're going to have a plus sign in here because you have multiplication going on in the denominator. But we're not talking about what's going on in the denominator. 3 is being divided, this 3 to the 6 is being divided by 11, so that's subtraction, but it's also being divided by this 8 to the 4th, so that is also subtraction. So be careful when you're doing this multiplication here that you don't put a plus sign there, even though you'll want to think that it is. So this is going to be log base 9 of 3 to the 6 minus, because it's being divided by, log base 9 of 11, but this 3 to the 6 is also being divided by this 8 to the 4th. This is log base 9 of 8 to the 4th. Okay, so then we can go ahead and put these exponents in front. So this is 6 log base 9 of 3 minus log base 9 of 11 minus this 4 log base 9 of 8. So this would be the extended version for number 11. Okay, take a look at this one here. This is log base 2. These are multiplication, so we're going to add. So log base 2 of 8 plus log base 2 of 3 squared plus log base 2 of 5 squared. We have powers to powers here, so 8. This 2 can go in front, log base 2 of 3, and this 2 can go in front here as well, so 2 log base 2 of 5. Now you could do this 3 squared, something that you could do if there are numbers that are smaller like this. You could do log base 2 of 8 plus, and then you could do 3 squared, which is 9, so you could do log base 2 of 9 plus, and then 5 squared is 25, so you could do log base 2 of 25. So if these are small enough, you could do it this way, or you could do it this way. Either way would be acceptable, but with smaller exponents. But if these are larger, it's better just to put it in front than to try to work out, like 5 to the 5th or something like that. All right, let me double check that. Let's see, 12. Yeah. All right. So we're going to move forward here. In this example, we have a power being raised to another power. So we'll want to simplify this first before we expand it. So this will be log base 9. 10 to the 5th to the 3rd is going to be 10 to the 15th, multiplying those exponents together. This is 3 to the 1st, so that's 1 times 3, which is 3. And then 11 to the 1st times the 3, so this is going to be this as well. Now again, 10 to the 15th is being divided by this 3 to the 3rd, and it's being divided by this 11 to the 3rd, so that's going to be subtraction. So we're going to have log base 9 of 10 to the 15th minus log base 9 of 3 to the 3rd minus log base 9 of 11 to the 3rd. And then we are going to apply the product property. So this is going to put that exponent in front. And then we can put this exponent in front. And then we can put this exponent in front. And so we have the expanded version of, or the expanded logarithm using those properties. All right, let me double check that just to make sure. So those are the properties we use when we're expanding, and again, that's a valuable lesson. The more valuable thing that we're going to need to be able to do, though, is to take an expression that's already been expanded and condense it down into a single logarithm. Move it down, and so it's one single logarithm. Okay, and again, this is going to be the most important because when we come to solving logarithmic equations, where this is actually equal to something, you remember when we're evaluating logarithms, we need to change it to its exponential form. Well, we can't change it to its exponential form until it's as a single logarithm, so we're going to need to do that first. Okay, so remember, the same properties apply, we're just going in reverse. So if this is plus, then that means we are multiplying the u number times the v number. So this would be the condensed version. So plus means multiply, division means subtraction, and then a power to a power multiplying exponents is a power to a power. Okay, so this would be down to its single version. Notice it's only one logarithm. When it says single logarithm, you're only going to see the word logarithm or natural logarithm once. Okay, let's take a look at number 17. Now, in a case like this, we have to recognize that we can actually take this 1/2. This is log of x divided by 2. So this is actually 1/2 log x. And whenever you see a single denominator, you want to think about factoring out that fraction. Okay? Now we have this exponent in front, so remember that's a power to a power. So we can rewrite this then log of x to the 1/2. But fractional exponents are roots, so this would actually be the log of the square root of x. Okay, so that would be the condensed version. So whenever you have a fraction, you want to kind of factor that out or put it out in front as a fraction. That then becomes a power to a power, which we have here, and then that is always a fractional power, is always a root, so you want to change it into its root form. Okay. Okay, here we have a power to a power, so we can put the power back where it goes. So this would be log of a to the 5th. That's a single logarithm, so that's all we would have to do there. Subtraction, you remember, is division, so this is going to be the log of x divided by y. Now I want to take a very important point here. Notice it says a single logarithm. I only use a single logarithm. It's very important because the common mistake here, what most students are going to want to do this divided by this. Okay, a couple things wrong. It's not a single logarithm, and this does not equal this. This is a totally different thing. Okay, so make sure when you're writing it as a single logarithm, the division is this divided by this, and that's all you do. Okay, I'm going to do a number more examples. Again, you can follow along as much as you need. Okay, number 20 here, we have a power in front, so this would be log of a and then to the 6th power. That would be your single version. All right, 21, number 21 here, a couple things going on. Again, this fraction, remember we want to take it out in front, so I'm going to do that first. Okay, so this is going to be 5 log base 2 of z plus 1/2 then log base 2 of x. All right, so now we have powers in front, so this is log base 2, so this is going to be z to the 5th, and this is going to be log base 2 of x to the 1/2. Now because it's plus, we're going to multiply these together. So the single log is log base 2 of z to the 5th times x to the 1/2. But again, this fractional exponent, we want to change it into its root. So this is log base 2 of z to the 5th times the square root of x. This would be the condensed version of number 21. We'll go ahead and do number 22 here. So again, it's plus, so I'm going to multiply, and then I have numbers in front, which are exponents being raised to another exponent. So this is going to be log base 3 a to the 10th plus log base 3 of b to the 5th. And then because it's plus, we're going to multiply those. So log base 3 of a to the 10th, b to the 5th would be the condensed version. All right. Similar one here where we're going to have, or where we have an addition. So the a and the b are going to be multiplied together, but we have these exponents in front. So log base 9 of a to the 8th plus log base, sorry for the scribble there, b 9, excuse me, of b to the 4th. And then because it's multiplication, we're going to have log base 9 a to the 8th times b to the 4th would be the 10th. Would be the condensed version. Okay, do some more examples again. I'll try to find some more difficult ones here. Let's see. Okay, number 24 here. Again, we have this fraction, so we want to take care of that. So this is log base 4 w plus, and we want to take that fraction and put it out in front here as a fractional power. So now we have powers to powers. So this is log base 4w cubed plus log base 4 of u to the 1/2. Because it's addition, we're going to multiply these together. So log base 4w cubed times u to the 1/2. And the fractional power, we want to change it into its w squared, its root form, so square root of u would be the condensed version of this. Okay, 24, double check, that's good. All right, this one here, again, is multiplication all the way across, so we're going to multiply these values together. So log base 3 of x times y, and then times z cubed. I kind of skipped a step on that one. If you're not sure how to do that, well, remember this goes over here, z cubed, and then we're just going to add those together. So I'm sure some of you are probably skipping a lot of these steps already, but I like to write them out so you kind of see where they are. But okay, so we have these fractions, so we want to put those out in front of all of these. So this log base 7, that's 1/3 goes in front, and this is going to be 1/3. Now there's already a 2 here, so don't forget that that's still there. Log base 7 of 11 plus 1/3 of, let's see, log base 7 of 5. Okay, so we can move this up here. So this is log base 7 of 6 to the 1/3 plus, now this is 1/3 times 2, so that's 2/3. So this is log base 7 of 11 to the 2/3. And then we have log base 7 of 5 to the 1/3. So because this is all addition, we know that that's multiplication. So we're going to have log base 7 of 6 to the 1/3 times 11 to the 2/3 times 5 to the 1/3. And again, we need to change this to a root. So the denominator is 3, so this is the cube root of all 3. So log base 7, the cube root of the 6, there's only one of them. Remember, that's the numerator. However, this is times 11 squared because the numerator is a 2. And then times 5, and there's only one 5. So this would be the condensed version for number 26. Now, we could multiply those all together if we wanted, but I'm willing to leave it like that for this example. All right, for number 27 then, it's all multiplication here because we have addition signs and we have powers to powers. So I'm going to skip a couple steps and do this all together. So this is w squared, and it's a plus, so it's times u to the 4th, and it's plus, so it's times whoops, sorry for the scribble there, v squared. So this would be the condensed version for number 27. All right, we'll go ahead and do number 28 here. Well, I'm going to move it up here first so I kind of see what's going on here a little bit better. Okay, number here, it's plus and it's plus, so it's going to be multiplication, and I have numbers in front. So again, I'm going to start taking some shortcuts here. So this is the 12, and it's plus times, and this 2 goes over here, 5 squared, and it's plus, so it's times 11 to the 5th. Okay, so this would be the condensed version. You could multiply those all those together and get a single number there if you wanted, but I'm not going to do that in this exercise. Okay. All right, number 29 then. We've got a few things going on. I'm going to rewrite it, making these fractional exponents in front here first, and then I might take some shortcuts there. Let's see. So this is 1/2 log base 6 of 10. And then this is log base, let me go back here. 1/2, then log base 6 of 11. So this is going to be 3 to the 6, so it's log base 6 of 3 to the 6 plus, that's a times, so it's times 10 to the 1/2 plus, that's times 11 to the 1/2. So both of these are fractional exponents, so those I can change. So the 3 to the 6th is still out here, but it's the square root of 10, there's only one of those, times 11, there's only one of those. So we can get this down a little bit better. The square root of 10 times 11 would be 110. So 3 to the 6th times the square root of 110 would be that one. All right, one more example here, number 30, and hopefully these have been helpful for you. I've enjoyed doing them. Hopefully as much as you've enjoyed watching them. All right, so again, I'm going to take a couple shortcuts here because we're at the end here and I need to move on. So plus and plus is multiplication. So this is an exponent in front, so this is log base 8 then of c to the 4th plus, so that's times a to the 4th plus, so that's times b to the 16th. So log base 8 of a to the 4th, b to the 16th, c to the 4th, just kind of putting those in alphabetical order as we would want to do that in most cases. All right. So that's, again, this is probably the most important part of the lesson, being able to take those expanded logarithms, getting down to a single, because when we go to solve logarithmic equations, we're going to need to do that and then change it to exponential in order to do that. All right. So hope those were helpful, and we'll look at the next video where we actually now solve logarithmic equations.